Okay, here's problem number 6 from assignment number 7. Find the point on the parabola y equals 2x that's closest to the point 1,4. Let me draw a diagram of what we're looking at. This parabola looks a lot like this. Kind of sitting sideways and opening that place. We've got a point which is over 1 and up 4, and I believe it sits above that parabola. Now we think that there's a location on this parabola that's closest to 1,4. All right? And all of the spots on this parabola, if we just do a little bit of work here, by dividing this by both sides by 2, I get y squared over 2 is equal to x. So I say that this location here on the parabola is in the form y squared over 2 and y. It's not your typical x and f of x thing because it's on its side, but it's in that general form. And that the distance between the point 1,4 and this point can be summarized as the square root of y squared over 2 minus 1 quantity squared plus y minus 4 quantity squared. That's the function that I want to minimize.
Please excuse the following interruptions from student leadership. Welcome
Now,
back and happy new year. Philosophy Club meets at lunch.
The trick that Eli and John used was to say, you know, if I minimize just the stuff under the radical, I will minimize that square root itself. So they changed this to big D.
Free practice ACT on Saturday, January 16th. It's open to all juniors at Berkeley High School. Students must sign up for the test and the counseling on
Okay,
Thursday.
and so this is the function that I'll actually minimize. It has the same idea as minimizing that function. So D prime. Oh, thank you. So let me take the derivative of that, and that's going to be 2 y squared over 2 minus 1 to the first power multiplied by 2y plus 2y minus 4 to the first power, and the chain rule is also a 1. Oh, no, it's 2, yeah, it's 2y over 2, so which is just 1. You're correct. All right. So if we expand this, we get 2, okay, I'm going to multiply this through first, and I'm going to get y squared minus 1 times y plus 2y minus 8, and then I'm going to expand this way and get y cubed minus y plus 2y minus 8.
You know what? That should be 2. It should be y squared minus 2.
And then it would be 2y.
Then you get the 2y.
Oh, sorry. Okay, let me just make sure I get this right.
That was right.
This is minus 1, but when I expand it, come on. When I expand it, that turns into a 2. And that's a 2y, and they cancel.
Yeah.
Great. And so now we have y cubed minus 8 is equal to 0, or y cubed is equal to 8, which leads us to y is equal to 2. So we found the y value, and then we plug that y value back into here, and we get 2 squared over 2, or 2 comma 2. All right? Now, was it Aiden or Ben who said, like,
My question's on the way that you did it in this video.
was it having to do with this step from here to here?
Yeah. He did it x2 minus x1. So, like he did it. He's also because he didn't have to do roots on it.
Yeah,
Meaning these two are flipped?
Yeah.
Okay.
Wait, he means they did theirs, like, they substituted the y squared over 2 in later.
Oh,
instead of,
okay.
like,
Yeah. Either way would be fine as long as, like in their case, they knew that it was coming on from the upper half of the parabola. Yeah.
Actually, my question was how you know, like which it's x2 minus x1, right?
Yeah.
How you know that.
And the answer is I could do it either way. and it's still turn
But
on.
like, where do you put the 1? Which x value do you plug it in for? That's what you're
Wait, okay, so the question is, like, our general distance formula is x1 minus x2 squared plus y1 minus y2 squared. And the question is, I've got two x values, a 1 there and a 1 there. And like in this case, I put them in that order, but could I put them in this order? And would it still be okay? And the answer is it would be absolutely okay.
It doesn't matter which.
It doesn't matter. It doesn't matter. All right.
Yeah.